Okay, let's talk about synthesis methods now that we are going to be getting into how to play around with those since you know how to use a poly already. We've created some basic monophonic synths already. Let's explore some of the classical methods. We're going to start off really easy with creating just the easy DAC. And then again here at the bottom. And then so you can see stuff, I'm going to connect everything up to a scope and a spectroscope as normal. I will move that down. And then with the spectroscope, this is for sure going to be, taking a look at that, going into color, and we're going to display as a sonogram. Now up here, I'm going to do all my processing starting from the top. I'm going to create a note in. You could use MIDI in and do it with MIDI format and MIDI parse and all that stuff the way we've been doing it before. But this is just going to be a really quick explanation of some of these different modes to show you exactly kind of what it is that we're doing. So we're going to start off with subtractive synthesis, which, guess what? That's what we've been doing already, actually. First thing I'm going to do is create an M to F that is going to control the pitch from the MIDI from note in and convert that into frequencies. Then what I'm going to do is I'm going to send that to a rect object to get a pulse modulation wave. I'm going to give it an initial frequency of 440, and I'm going to give it a duty cycle of 0.5, so that's a square wave, and then that's immediately going to overwrite the frequency, so that does not matter whatsoever. Next, I'm going to take that and I'm going to duplicate it, and I'm going to add a little bit to it. I should have duplicated that as well, but such is life. And what I'm going to do is before the M to F, I'm going to subtract 0.25 from the MIDI value and connector up. Then I'm going to duplicate that one, and I'm going to add 12.25. So this is going to give me an octave, and it's going to be really fat, and that should be cool. Obviously, I need to multiply that by 0.33 because I've got 3 rectangles coming in to create 3 pulse width modulated waves. And then I should be able to hear that. Let's take a listen. Okay, obviously need an ADSR and need to do something with that for the velocity. So divide by 120. Divide by 127 and maybe not accidentally hit my screensaver key. And that's going to go to an ADSR. I'm just going to use some really basic defaults. 10, 20, 0.85, and 250. And you can already see down here it's getting kind of psychedelic. I'm digging it. Okay, let's insert a multiple tilde object, connect, and this is mostly ready to go, except it is missing one of the central things of subtractive synthesis, which is a noise source and a filter. So subtractive synthesis is all about creating really funky harmonics. In fact, let's make this even funkier. Let's make that minus 24, so 2 octaves down plus a quarter, an eighth of a tone. Let's get our classic in live.dial, and what we're gonna do is take a look at that. This will be the blend. Zero to 1 point. Init enable 0 unit style float. Cool. Then we're going to create a noise source. Pink noise. Yes, please. Multiply by 0.33 just to keep it within the same managed output range as before. And then we're going to take that, and we'll bring that down. Going to duplicate those, and we're going to make them just regular multipliers. And then with this guy, we're going to connect it up like so. And remember, before I connect it to this set of square waves, what I want to do is use exclamation point minus to do the inlet reversed subtraction. 1 point. Connect, connect, and now this will allow me to blend. After I turn this back on. And ooh, well, hey, you know, it might help if I then connect this guy up to there as well. And I'm not sure that that negative 24 is working. Let's just do 0 point minus 25. All right. Okay. Well, that is not sounding like something is going right. In fact, something is going very, very wrong. What is going wrong here? All of those are going correctly through. That's getting modulated. ADSR. ADSR is correct. Why am I not hearing anything with blend? Ah, because the range. Hey. My range did not go through. Why are you not? Let's try that. That sounds considerably better. Okay, and in fact, I'm going to bump that up to 0.5. That should be even. You know what? We might as well go for broke. I'm just going to delete it, and we'll go to 100% for the blend. Okay, that sounds like everything is working. So now we've got some really interesting stuff going in and creating the sound, but still not subtractive. Classically speaking, subtractive is based around filtering. So you know where this is going, and so do I. We're going to create a biquad, and then I'm going to break some connections here and here, and then connect them here and here. And then I need a filter graph. Let's do it up. Filter graph, and let's get edit mode. And hook it up. So traditionally, for a subtractive synthesis setup, what we've done is we've created some interesting waveforms that have interesting harmonics. We could blend in a little bit of noise. And then what we're doing is we're adding a filter. And adding that filter in, just blew the cue up. Well, let's try and maybe get that back a little bit. All right. Yeah, adding that filter allows us to get rid of some of the upper harmonics, or the lower if we go the high pass route, in order to get the end result that we have coming out of biquad. And that is the essence of subtractive synthesis, is that you're creating complicated waveforms and then you're using a filter to subtract out parts of the spectrum that you don't want. And you can really see that down here on the spectroscope.